Hi, everyone. Welcome. This is the Autodesk Vision series, and in the next 30 minutes, we're going to talk about virtual production. My name is David.
And my name's Ben.
And we're going to first do a quick introduction of each one of us. I started at Softimage early on, and my first contact with what was to become virtual production, motion capture in film and games, was on Jurassic Park when they built that device there. You may have seen that before, the dinosaur input device. And that made an impression on me because at the time, it was the first time really that you connected the craft of stop motion in this case with computer graphics and animation by providing the talented stop motion people at Phil Tippett with a device that they could use the way they're used to animate. And that marked me at that time, and ever since then I've been very focused with bridging the virtual world and the real world together. Then I moved on to Manix, where I had the chance to meet the people inventing virtual cinema for the Matrix movies, Kim Library, George Borshukov. Later, now, working at Autodesk in industry relation and business development, and in between, doing some committee work here in Los Angeles with guilds and societies on previs and on virtual production, which is a committee that's going on now of 6 guilds and society in Hollywood, the American Society of Cinematographers, Art Directors Guild, the VES, the Previs Society, Producers Guild, and the International Cinematography Guild, all looking at virtual production and how this new workflow is going to take its place in movie making. To you, Ben.
Thank you. So my name is Ben Guthrie. I'm the Virtual Production Product Manager at Autodesk, and thanks for joining us here at the Vision Series. I joined the Autodesk team last year after about 15 years in AAA games and feature films. Through this time, I've been primarily focused on motion capture, reality capture, and a bit of virtual production. My role at Autodesk is to look at the problems that exist today in virtual production and attempt to find some answers. What David and I wanted to do today was talk about the vision of our vision for the future of virtual production and look at how we can aim to address some of the current issues. And we'll look briefly at some of the development from our partners and clients, as well as some developments from Autodesk.
All right, so the structure of our talk is going to be along these 3 axes here that we are calling the problems to solve in virtual production in order for this to become easier to use, more effective for making linear content, which the 3 problems are capture, reality capture and motion capture, the camera, the virtual camera, and the simulcam, and rendering, which is rendering in real time in some form or another. Before we get into the details, at a higher level, what is virtual production? This is something that people ask, and this is our current definition of virtual production. I'll let you read it. The keywords in there are content creation. So virtual production is about production. And it's immersive, meaning you immerse yourself inside your content while you're creating it, as opposed to looking at it on the screen. And the goal is to film virtual worlds in camera. That's the ultimate goal. And so virtual production has been around for a while already. You've seen, of course, we know about Jim Cameron using the technology. Peter Jackson used that technology, actually was right at the beginning of all this. Alfonso Cuarón here on Gravity, Steven Spielberg, Roland Emmerich, Sean Levy, Robert Stromberg, Gareth Edwards on Godzilla, the Wachowski siblings on Jupiter Ascending. The list is growing as this workflow is being embraced for parts or the entirety of a movie. This is a partial list of the movies that have used virtual production. The first recorded use of virtual production was on the first Lord of the Rings movie in 2001. Peter Jackson used a virtual camera in one of the scenes that he wanted to figure out. And from then on, there was Robert Zemeckis at IMD, where I think, Ben, you've been working on these movies such as The Polar Express, Beowulf, Christmas Carol, a few others, they're not all there. And then, of course, there was Avatar. Avatar was the big event that put virtual production on the stage, and very successfully. That was our big milestone. But since then, and it's, again, in chronological orders, many other movies have been made using that workflow and that technology. Going on essentially every year, the number is growing. And we're looking at now in the last few here, like the not out yet, the movie The Walk has been using virtual production to visualize the two towers that are not there anymore, obviously. Then Warcraft is going to be one. There's about a dozen movies they're doing using virtual production technologies and workflows in production right now. So Joe Lettieri here, you recognize him, most of you, I'm sure. Joe Lettieri is the principal and the senior visual effects supervisor at Weta in New Zealand. And recently he was at FMX in Germany, and there's a bit of an interview here that was provided courtesy of FX Guide and Mike Seymour where Joe talks about what virtual production is at Weta, and we're going to listen to that.
So looking forward, what are the kind of things that you would like to see Weta doing for the next 20 years? I mean, 20 years from now seems a ridiculous amount of time, but you've got to be planning ahead for at least a decade right now.
Well, what I see happening more and more is this idea of virtual production becoming a tool that's comfortable to directors and also to crews. When Jim rolled out this idea, Jim Cameron, when we were doing Avatar, this was a big deal, the idea that you're going to shoot this whole movie, virtually, or large chunks of it, and bridge that divide between virtual filmmaking and live action filmmaking. But you can see, for example, on the Hobbit films, Peter really took it to heart. When we got to the end of Desolation of Smaug, there was a scene that where the dwarves are trapping Smaug inside the old forges where they relight the fires. Well, Peter shot that knowing what he wanted Smaug to do, but just getting the green screens of the dwarf actors for live action photography. And then he had our previs team, Dave Clayton and his team, just put together lots of animation to block out all the action that these guys did. And they roughed it out, and then they refined it, and Peter put cameras on it, and he built the whole scene from that, going from what he shot on green screen to these completely virtual shots. And that experience worked out so well for him and for us that he really embraced that when we came to do the Battle of the Five Armies. So Peter spent a lot of time on the virtual stage with stunt performers, with our big, virtual landscape for the battle scene, and with his virtual camera, and just went in there and, minutes-long animation takes with dozens of performers and thousands of background, characters were just available to him to put a camera on and fly it around and bang out his shots and work out what he wanted. Sent them up to editorials, get a cut going, look at what was missing, go back and reshoot it. We had this whole process. We were just constantly looping through between visual effects shots and previs and stage. Those barriers have just fallen, so it's no longer a linear process of shoot something, hand it over to visual effects, they'll put in the missing bits, and you're done. Now it's we start shooting in visual effects, and then we loop back to live action, and then we come back and do a little more previs and work that into the scene. And so it's all a kind of a big two-way street now.
So it's a great explanation of virtual production today. Now, virtual production in the future, our vision is that all filmmakers will be able to do this one day. So today, it's totally feasible, but it takes a Weta with all their firepower to be able to make virtual production movies like that. But our goal is to make virtual production as easy to use as traditional film production, so that it becomes part of normal production for those filmmakers who want to use those kind of technology. So talking about the problems to solve to get there, passing the microphone to Ben, talk to us about reality capture.
Awesome. So when we talk about reality capture, the problem we're attempting to solve is the idea that we need to accurately capture what has happened inside in 3D. So the digitally modified films being made these days need many real environments, props, and characters to be digitized. For example, if we want to modify a character's face, cast a shadow from a character from a digital character onto a real floor, or add digital explosion that interacts with a real environment, we need to know what the real world looked like first. So creating these digital assets from scratch can take a long time, and past scanning methods cause artifacts that were hard to work around. In addition to that, we often get limited access to actors, environments, and whatnot. So methods of capture have to be both fast and predictable. So photogrammetry offers both fast acquisition and top quality textures to match, often making it the right solution. You can head to location with no more than a digital camera and return with the material needed to create a world-class model. So being announced here, I believe, announced here as Memento. It takes advantage of one of the best photogrammetry engines available and combines it with our own internal Titan engine capable of working with billions of polygons. We've even seen this run on video footage for those that need to extract geometry out of video. I'll give you a little peek into what Memento looks like in the inside. So with Memento, you just select a sequence of images and import it. And you have the ability to check while you're on location to make sure you can get something good from it rather than having to wait to find out later. Once you got it, just give it a name, send it off to the cloud. Currently, this is a cloud-based solution. And then they'll send you back a digital scan of this, which you can see pop in here. This is a scan courtesy of one of our partners in London. This is a photo booth with 100 digital cameras. So you can pull this mesh in and just run some quick processes on it. It'll detect and find some problems for you, help you fix the problems in a semi-automated manner, and allow you to intervene where you need to. Even do a bit of sculpting and cleanup if you need to in the package. And then when it's all done, you can save it out with cameras and bring it into your DCC and do your cleanup in there. So Tatjana's got a presentation at 5 o'clock today with full in-depth look at this stuff, which you can sign up for that one. I'm assuming there's still a bit of space left. Come and see that. So that's my look at reality capture.
All right. So reality capture, and yes, there's more tonight at 5. Come back in this room. Motion capture. So motion capture is at Autodesk, Motion Builder and Motion Capture are synonymous, and Motion Builder is a tool that you could consider the standard on motion capture studios today. You can see it on the floor here at SIGGRAPH 2015. It's in at least 3 or 4 of the booths, our partners. You can see it at OptiTrack. You can see it at SolidTrack in the French Quarter. The Vicon booth has it. And the Motion Builder won a Scientific and Technical Achievement Award last year in 2014, the code base for its contribution to the film industry. The version 2016 is available now. You can download it, try it for 30 days. There's a number of improvements in it: story tools, F-curve editor, increased FBX file size limit. It keeps on moving forward for the people who are using Motion Builder for motion capture and extending it to virtual production. To find out more, you can see us at the end of the show, at the end of the presentation for more questions. Here we want to focus on the vision part of our presentation, and we want to move on to the next section, which is about cameras. So cameras, I think it's good to remember that just 6 or 7 years ago, most cameras on set were mostly mechanical devices pulling film. But since then, there's been a total revolution, as you know. The digital motion picture cameras are now all over in the large majority of sets. And these cameras are doing what film cameras were doing, capturing stream of images, but they also do a lot more. They are really computers on set. And they generate, they capture information of all sorts about the lens. They have audio built in. They have all sorts of metadata that comes out of the camera and are being sent, sometimes captured and used in the rest of the production, not all the time. But it's important to realize that we have a different beast on set now. And this beast is evolving. It's a camera, but it's a computer, and it's doing things now and it's going to do more. And to talk to us about what it could do more, Ben?
So the problem with we're trying to look at with in virtual production is how do you visualize digital content while you're on set. So in many of the visual effects shows, at least in the past, the director and crew have had to imagine what the digital characters and set would look like. Consider the middle shot here, where through the camera the cameraman gets to see a broomstick in the place of the flaming character on the right, and imagine all of his training must be a bit frustrating at the time. So the obvious risk here being that the director and the cameraman might have a different vision of what that should look like, and then the visual effects house has to clean that up in the end. With virtual production, you get to visualize the character in the shot the way we would in a live action character, and obviously the more accurate this visualization is, the more likely it is that we're going to get the perfect shot while we're on set. A similar principle applies to the environment on the left. As a director or cameraman, your framing is often affected by light source and horizon, as you know, some things. It would be hard to take full advantage of your skills without knowing where they are while you're on set. So we attempt to address this in virtual production with a couple of ways. First of all, there's the virtual camera. So the virtual camera is like putting virtual reality on the cameraman and director. And through these devices, we see just the virtual world, none of the live action stuff. And you might have seen some of this stuff happening from the making of footage for Avatar. They used it quite extensively. The simulcam, on the other hand, includes the real world and tracks its relative position and superimposes the virtual content on it. We'll show you a little video here that Microsoft has put together to show off the HoloLens recently. I'm going to use it because it shows a version of a simulcam in action. Take note of the augmented camera simulcam that Microsoft has constructed to replicate the experience that you see within the HoloLens, and consider how important it was for the cameraman to see this virtual content live.
With HoloLens, Autodesk can extend their existing software to provide new value to their customers. First, you'll see that we're using a special camera today. With this camera, we create a display technique that's like putting a HoloLens right on the camera itself, so that the entire audience can see what my colleague Dan is seeing.
Today I'm going to be using Maya by Autodesk, and I will show you how HoloLens doesn't need to replace the workflow I have mastered, which would be very costly, but instead can extend my existing tools and add spatial understanding to help me visualize my work better and improve my productivity. So let me put on my HoloLens and show you what I'm working on. So right here in Maya, I have my motorcycle that I've been working on. And to the right, I have a holographic representation of the bike. And everything you see, the stage, the motorcycle, and the toolbar, can all be seen on my HoloLens. And everything I do in Maya instantaneously updates on the hologram.
So that, obviously, the CG assets on the table beside him weren't really there, but through the simulcam, we get to see what he's seeing in the HoloLens. But over recent years, we worked with companies like NCAM and SolidTrack and Lightcraft, and they've been working to iron out kinks when it comes to augmented and virtual reality. And we believe that the investment we're doing with companies like Microsoft and the work we see on set here will help make virtual production easier for filmmakers in the future. David.
Right. So the last category of problems to solve in virtual production is rendering. So you're on set, you have a virtual camera, there's a lot of work that's been done before to capture reality and motion, and you're looking at that. How good does it look? Today, it's a little bit low resolution, let's say, and filmmakers have to do a leap, an act of faith to see or visualize in their head what the final result will be. And we want to show you here two different take on how the future of rendering in real time on set could look like. The first one is a project from Kevin Margot. Kevin was perhaps going to be here. Kevin, are you here? No, he's not here. We have it on, have him on tape. And his project is really interesting because it's an independent movie that he is doing, a short. And he does not have a big, huge Hollywood-level VFX budget, but he took it upon himself to advance the workflow so that he could see in his virtual camera a better representation of his final result. So here we have a video that's been done by our partner V-Ray in conjunction with Kevin. Let's have a look.
Last year, we were able to basically get V-Ray App SDK to go inside a motion builder and give us live rendering on the GPU inside of a standard frame buffer.
Right.
This year, we're doing something different. What are we doing?
To connect motion builder directly to the V-Ray cloud using just a public internet infrastructure. So what we're doing right now is just getting all the data inside the motion builder using the app SDK, and then we're sending this data to the V-Ray cloud, distributing the data inside the cluster in a very fast manner using infinite band. And when each frame is ready, let's say 10 to 15 milliseconds or something like this, then we are getting back the frames, compositing them, and we are streaming back just ordinary JPEGs. So you can use any kind of device like iPhone or even desktop browser, and you can be everywhere in the world. It doesn't matter actually.
So you could be capturing here, and
Yeah.
you could be viewing it in Australia.
Yeah, exactly.
We're going to be tapping into the scalability of GPU rendering and streaming back to us onto the monitor here an amazingly high fidelity image, multiple times greater than what we could do locally.
In our flight to California, actually, we tried to use the V-Ray cloud from the airplane. We were able to do some rendering inside the V-Ray cloud, and it was pretty amazing. It
Yeah.
was like, I mean, history.
We can also art direct lighting. At the same time, we're capturing the performance and filming the scene. We can set dress to create, dynamic compositions the same way they would on a live action set. The actor can get a better sense of their place in the world. They can feel out the environment, be able to imagine or project themselves into the scene, inform their acting. Last year I had what I was calling a Polaroid mode, where I would hit pause and it would kind of develop or resolve to something that was less grainy and clear. And now what we've got, because we're tapping into the cloud rendering and scalability, is I don't have to do that anymore. I'm seeing what I saw last year when I was freezing the frame. I'm seeing that in real time at interactive frame rates now. Again, this all kind of alludes to a much more organic experience of being able to find the shot that works for you in a natural way.
So this is an amazing example. What we just saw, the part that blew my mind away, is that they were able to have their final render, essentially, in the cloud on a number of cores, rendering, not only rendering fast enough, but the communication between the local CPU and the cloud fast enough so that they could have a real-time feedback on set. So that's definitely one avenue for the future of rendering in virtual production. And there's another one.
So the other one we're going to look at real quickly is the use of game engines. Game engines currently offer us the ability to replicate many of the physical properties of a real camera, and they can also offer enough visual fidelity to allow the director to make sufficient informed decisions on set. As you might have heard, we've acquired a game engine, STINGRAY's announced at the show. It comes with a number of additional benefits associated with being made by the same company that makes your digital content creation tools. Though STINGRAY is initially being developed to satisfy game developers, we're obviously excited to see the potential benefit that can be associated with virtual production. And so for those of you that haven't seen it yet, there's a quick video we'll show you here.
Making your game successful means making your game stand out in both terms of gameplay and visual style. And in STINGRAY, you have a powerful new rendering system that can deliver superb visual fidelity. STINGRAY's renderer uses physically based shading to make sure your materials look great and mimic the appearance of textures and surfaces you'd see in the real world. You can create stunning lighting effects in STINGRAY, which has a high-performance system for lighting and real-time reflection effects. You can also use our Beast global illumination tools to bake realistic-looking lighting and shadows to give your game a great look with less performance impact. Create advanced particles, such as lit particle effects with dynamic shadows, quickly and easily to add the ambiance your game levels require. STINGRAY also offers easy-to-use post-processed visual effects. Effects like depth of field, motion blur, lens distortion and lens dirt, chromatic aberration, and many more help add the finishing touches to your game. Regardless of what kind of game you're making, STINGRAY can help you bring it to life and make sure it looks amazing.
That's the fast view of STINGRAY.
And with STINGRAY, I think we have another approach to rendering where you have now a game engine, highly interactive, that can be connected to the virtual production workflow, possibly, in the future as we go forward. STINGRAY is just coming out now. It's version 1 being shown here at SIGGRAPH. And the version 1 is very focused on the game market, indie games market, as you've seen in the video. But as it is now out. We're looking at all the applications that could come out of a game engine now that we have one at Autodesk. And we're looking forward to work with Autodesk clients to advance the technology, take the requests moving forward. So this was our short 22 minutes overview of our vision for virtual production around these three main axes: capture, camera, and rendering. If you want to, you can contact us both, Ben and I, at the email address over here. We're here to answer your questions. Do we have time for questions? Maybe a few in the audience, if there's any. Go back a slide. Oh, I'm sorry. OK, thank you.
David, could you just comment a few minutes on the intersection between virtual production and virtual reality?
Yes, that's true. I should have brought that slide as my backup. So that's a question that we've been asked a lot at the Virtual Production Committee in particular, when VR exploded on the scene a little more than a year ago, when Facebook acquired them, and then Magic Leap acquired them, and so Magic Leap was acquired by Google. So we all know that story. A lot of focus on VR and AR at the moment. So VR is a new medium. VR is going, if it's all going to work like the projections are, it's going to be a new medium that will take its place besides film, television, games, and there'll be VR, new medium. Virtual production is about production. Both VR and virtual production, virtual reality, virtual production share or will share the same immersion tool. The key word between the two is immersion. When you're experiencing a VR experience, you're immersing yourself as an audience into a VR experience. Virtual production, you're using the same immersion tool, but to create your content. So it's a production tool. In the most advanced case, you're looking at a simulcam, which is an augmented reality device, just like the HoloLens, exactly same principle, but in a form factor that is adapted to the cinematographer or the filmmaker. But the technology behind it, as far as we're concerned for software, is the same. It's a different device completely, and the principle of immersion is the same on both sides. So virtual reality, new medium, virtual production for production. Does that answer the question? OK. Other questions?
Yeah, as far as STINGRAY, is it capable of doing virtual reality output at this point, or is that coming?
Yeah, it supports the Oculus as it
supports
is.
Oculus.
And they're looking at the Vive next and then following through on the rest of the device.
Great.
Yeah.
Other questions? No other questions? Going one, twice, 3 times? We're right on time. Thank you very much for joining us today.